Welcome to our presentation on cloud computing for regulated life science environments. The topics that we will be discussing will be presented in 4 parts. The first part is characteristics of cloud computing. The second part will be considering whether to use cloud computing. The third part will be about what you should find out about your provider before you engage them. And the fourth part will be cloud computing issues and their influence on validation. So I think I'll turn it over to Leo, and I hope you enjoy the presentation. Thank you.
Thank you, Patty, and I'd like to welcome everybody to the fourth and final part of our presentation. In this part, we're going to take a look at what issues cloud computing brings to the world of validation and compliance. And we're also going to talk about what steps need to be taken to successfully qualify and validate cloud technology. First off, we need to establish that a cloud service provider is just another vendor to your company. The CSP is highly specialized in what they do, and they also provide services to other clients. And just as an example, some other vendors you might have are, for example, API suppliers, equipment vendors, contract manufacturers, companies like that. So what do we do with any vendor in our industry? We qualify them. We check their quality system. We go over their SOPs, their training programs, their policies. And depending on the criticality of the product or service they provide, we audit them, either in-person on-site audit, or a paper audit, or a telephone interview. So what will a viable CSP have? They need to either understand FDA regulations and requirements, in particular Part 11, or at least be willing to learn and understand them and work with the regulated company to achieve those goals. The right to audit is also a must. The CSP has to allow the client to audit them, but it's also important to remember that third parties, like FDA inspectors, for example, have to be able to audit them as well. In relation to understanding the applicable requirements, the CSP also has to understand the qualification process for IT infrastructure, the validation process for software applications, and also for a platform. And this last bullet point here, in my opinion at least, is pretty important. The CSP needs to understand and adhere to well-known standards or frameworks such as, for example, COBIT, ITIL, ISO 27000 series, and there's also one nice tool put out by the CSA, which is the Cloud Security Alliance. It's called the Cloud Controls Matrix. And what the CSA has done with this matrix is they've identified 11 control areas such as compliance, information security, operations management, resiliency, security architecture, and they have taken these control areas, broke them down into specific controls for each one of them, and then aligned them to frameworks and standards such as COBIT 4.1, HIPAA and HITECH Act, ISO 27001, FedRAMP, PCI, and several others. And so where this is useful to anybody that wants to evaluate a CSP is this matrix gives you close to 100 specific control specifications that you can go to any CSP and ask them all those questions and see what answers you get, and then audit against them. And this makes your evaluation process for CSPs and then eventually the audit process so much easier and so much more consistent. Beyond this presentation, if everyone has a chance, I suggest check out the CSA and their Cloud Controls Matrix. I think it's a very good tool. So let's say we have analyzed our requirements, we have elected to utilize cloud technology, we have selected a provider. How do we qualify the infrastructure? Well, first off, any cloud infrastructure relies on virtualization. And the basic concept behind virtualization is that you abstract the physical resources and then control how much of those resources are presented to virtual machines. In the sample illustration from VMware, for example, we can see a basic idea of how virtualization works. At the bottom, we see a representation of the physical layer, the processors, memory, hard disk drives, network interface cards, and this all represents the physical hardware that you would typically see in a data center or a server room. On top of that hardware, we have a small piece of software called the hypervisor. And the hypervisor is represented in this illustration by the VMware virtualization layer. And the job of the hypervisor is to facilitate all communication between the physical hardware and the virtual machines in which operating systems are running. So what's the point of going through all this trouble? Well, you could have one physical box with 16 CPUs, and you can install 16 different virtual machines on that one box. And by using the service console, you can assign a CPU to each one of the virtual machines. So what you've done in effect is taken 16 separate physical boxes and consolidated them all into one. We could talk for a very long time about the benefits of virtualization and what you could possibly do with it, but this is just the basic crash course on what it is in case nobody's ever heard of it. Since cloud technology is a pretty broad field, I'm going to go through each of the service models one at a time, and I'm going to start off with infrastructure as a service. Our goals here are going to be to qualify the physical hardware, qualify the hypervisor and the tools that we're going to need to control it, test high-risk functionality of the hypervisor, and finally validate the deployment process for virtual machines. Let's start with the IQ. As we talked about a few slides back, the CSP is a vendor, and therefore needs to be qualified as such. The qualification process, which should include at least one on-site audit, will ensure that the vendor is capable of providing the back-end infrastructure to your environment. And what this means is that you would have verified that the vendor is qualified to support your IT needs. You can draw comparisons between a CSP and an internet service provider in the sense that an ISP delivers data connection to your environment, and you rely on them to be able to manage and maintain that connection. So beyond this, we need to IQ the physical equipment within the scope of our control. Since in this presentation we're focusing on operating in a regulated world, that means that we'll probably be running in a private cloud. And as such, we should have control over our physical infrastructure, which makes installation qualification possible. So as we execute the IQ, we document everything that we normally would in our own data center. We need to identify all physical components, identify the hypervisor, make sure that it's compatible with all of the hardware and software that we're going to use. And at the same time, we need to make sure that all the components and specifications meet our requirements, which we documented back when we were analyzing our current state of IT. I do want to acknowledge the fact that this qualification process at the vendor site is quite difficult and time consuming. And some vendors who are more accustomed to working with regulated companies will provide personnel for you and help you out with the qualification process. There are, in addition to that, other companies that have data centers that are qualified from the ground up. What I mean by that is that these CSPs have performed installation qualification testing while they were installing equipment in their data center. And they've documented everything down to the memory module. So what you get with a setup like this is a pre-qualified hardware and hypervisor on top of which you can build your own cloud environment. And beyond that, to maintain compliance, CSPs such as this perform all upgrades and changes under formal change control, which means that the infrastructure remains qualified even as updates are being made to the configuration. Performing an operational qualification for infrastructure as a service is similar to an OQ for software, and in this case, the software is the hypervisor, which controls the allocation and deployment of resources. So typically, we would test the ability to deploy different types of virtual machines, ability to manage and reallocate resources, monitoring and alert systems, routing amongst VLANs and virtual networks, and so on. You may also choose to perform functional and stress testing on the hardware, or maybe failover mechanisms for backup systems. Basically, the types and amounts of testing will be driven by the level of risk that your organization has chosen to accept. Once you have a qualified infrastructure, you need to lock it down. Everything needs to be under change control. As I mentioned before, some CSPs have change management built into their procedure, which makes the whole process streamlined and much easier for the customer to manage. Whether the CSP provides this type of service or not, you'll need to have a carefully crafted service level agreement, or SLA, in which the CSP agrees that all changes to your infrastructure must be documented and must go through the change control process. For the most part, the cloud provider staff will be doing all of the hands-on changes, such as upgrades and repairs. And for this reason, and just as a general good practice, the provider's IT staff who will be responsible for your equipment should undergo GXP training so that they have a fundamental understanding of regulations and what is allowed and what is not. And the whole point of going through all this is to establish control over your environment. Whenever there's a question about qualification or validation, we should always ask ourselves, do we have sufficient control that is commensurate with the level of risk that we're willing to accept? If not, then we will need to develop different and better ways to accomplish our goals. As we saw, qualifying infrastructure as a service can have its challenges, but it's fairly straightforward. Platform as a service, on the other hand, brings a couple more challenges. The ideal way to set this up is to install your operating system, your databases, and your platform or your environment on top of a qualified infrastructure. However, because the platform model is typically used for software development and deployment, it's typically offered as a public cloud service. If you are going to use platform on a public cloud, be sure you know what services and resources you'll be sharing with other tenants, and also what level of isolation you can expect. If, on the other hand, you plan to deploy platform as a service on your own private cloud environment, the main goal of qualification activities should be to ensure compatibility between the system and your software. As we saw, qualifying infrastructure as a service can have its challenges, but it's fairly straightforward. Platform as a service, on the other hand, brings a couple more challenges. The ideal way to set this up is to install your operating system, your databases, and your platform or your environment on top of a qualified infrastructure. However, because the platform model is typically used for software development and deployment, it's typically offered as a public cloud service. If you are going to use platform on a public cloud, be sure you know what services and resources you'll be sharing with other tenants, and also what level of isolation you can expect. If, on the other hand, you plan to deploy platform as a service on your own private cloud environment, the main goal of qualification activities should be to ensure compatibility between the system and your software. Validating software as a service can be quite more complex than infrastructure or platform. The ideal setup would be if the SaaS provider hosts their software on their own infrastructure, either in their own data center or in a private cloud. If this was the case, they could qualify their infrastructure and run and validate their software on top of that, so they would have a fully compliant SaaS offering. The problem is that most SaaS providers run their applications on another company's unqualified platform or infrastructure. And if this is the case, then you would at the very least want to be able to audit these other companies. But what you'll find is that it's not possible in some or even most cases. One option to resolve this problem is to purchase a license or purchase the software itself from the SaaS provider, and then you can run it on your own data center or on your own private cloud. And so in this kind of configuration, you would have complete control over the entire system. But of course, the benefits that you would typically see as a result of implementing cloud technology, they start to diminish as you try to retain more control in order to stay compliant. So, for example, the cost of hardware, software, time and expertise required to set up and maintain the system, these all go up, sometimes to prohibitive levels. When evaluating software as a service providers, we should start out with some basic starting points. For a life sciences company, depending on which regulations it has to comply with, all of these may not be required per se, but I personally would view them as requirements for good practice. To start off, the SaaS provider should have a robust quality system, and if the software that you're using can be classified as a medical device, this would be a regulatory requirement as well. They should follow a solid and documented SDLC process, have dependable software testing plans, processes, tools, and personnel, have change control and perform regression testing after the changes are made, and they should understand your regulatory burden and help you comply with any regulations that you need to. So really what it comes down to is that a SaaS provider who designed and developed their software to be compliant from the very beginning would be a much better choice versus a company who had a nice standalone product and then they try to add controls to it to make it compliant, and then on top of that start offering it as a service over the internet. So are there any cloud providers out there who are able to support regulated companies? Yes, there are. And I can mention a few examples right now, but there are of course others beyond this. So here are some examples. First, a company called Business and Decision can provide data center solutions where they do qualification testing and provide all the documentation required for FDA compliance. And they also control and document all changes under a formal change control process, and they support on-site audits from their clients as well as third parties such as the FDA. Online Tech is another company that offers compliant hosting solutions to their clients. Their SOC 2 independent audit reports provide details of audit results relating to over 150 control areas, and they also allow on-site audits. For platform as a service and software as a service, although there are companies out there that offer services to regulated companies, In my personal opinion, it's better to deploy the platform or the software on your own qualified infrastructure. There are some open source multi-language platform offerings, such as, for example, Cloud Foundry or Staccato, that will enable you to do this. And a good example of a SaaS application is OpenClinica, which can be deployed and validated in a private cloud environment. So from just these few examples, I hope it's evident that cloud technology for life sciences is not a dream, but a real potential option. And of course, as always, not every solution is advisable or even possible for all problems, so a great deal of care should be taken when making decisions such as these. To summarize our presentation, we've gone over the different characteristics, deployment models, and service models of cloud computing. We've discussed the benefits and risks associated with the different types of services. We have also talked about the things that need to be considered as part of the selection process when choosing a CSP, and also some of the tools that we can use. And finally, in this last part of the presentation, we analyzed what is involved in qualifying and validating the different types of deployment models. Infrastructure as a service is perhaps the most straightforward to implement for a regulated company, because you can retain most of the control over your resources. But with this control come higher costs and IT overhead. Platform as a service can be a good choice for deploying software, as long as the platform is running in a private cloud or an infrastructure that's under your control, such as, for example, an in-house data center. And software as a service should be developed with compliance in mind from the very start, then validated for its intended use, and maintained under change control. The change control part of this is very hard, if not impossible, to do if the software is offered as a public service. So the easiest way to implement SaaS is, once again, in a private or a community cloud. And now, some final thoughts. Cloud services, as an umbrella term, is still fairly young in terms of computer terminology. But really, the technology used for cloud offerings is not new. What's new is how we're using the technology and the types of services that are being offered. The lack of concrete standards and the fast pace of innovation has made the word cloud a buzzword, and the field in general as a sort of a wild west of providers. Some of these providers do see the need for compliant cloud services and do offer services geared towards regulated companies. With updates to IT frameworks such as COBIT and the continued work of organizations such as the Cloud Services Alliance, the field of cloud computing is in fact maturing for the better. But one fact that I think will always hold true is that, as we all know, not all cloud technology is right for every organization, and not every situation can benefit from cloud technology. But I do think that it's at least worth considering the use of some cloud services in most cases. This concludes our presentation. I would like to thank everybody for watching, and please feel free to contact us at Globio if you have any questions.
Thank you for your interest in our cloud computing presentation. We started Globio because we saw a lot of inefficiencies and waste in the industry. We exist to help make FDA compliance efficient and to lower costs. Our core value is value through innovation, and we not only believe it, we live it. Please contact us today and see how we can help you. Thank you.